Now I need to see how to share my screen.
Yeah, there should be a little share button on the below the fourth button down on your panel. There's an orange button and then two green ones for your webcam and your mic, and then the next one is a square, looks like kind of like a screen. Or you can go into the sharing. You can go into the sharing one, and it says show screen. Oh, let me change presenters. Sorry, my bad. I didn't change presenters. I faked you out, dude. Sorry.
All right.
There we go.
What are you seeing?
I can see your screen.
What screen are you seeing?
The water and a bridge.
Well, that's on all. I mean, I've got 5 screens, so I'm trying to.
Yeah, I just see the water and the bridge. I don't see any presentation or anything, so maybe it's your second one. Maybe it's
not that one. Not that one. Not that one. No. Hold on.
I see it. I see it.
There we
Outlook.
go. This is the one I want.
I now see a water with a bridge.
All right. Let's see. Do you see?
There should be like a show screen button under the sharing. Yep, there we go. That's your presentation.
Okie doke. Let's get started then.
Okay, awesome.
I think this is what we want.
Okay, I'll go dark on the mic and you guys can go at it.
All right. So let's get started. Just a little bit about myself. And thank you for being here. And please think about putting together a presentation yourself. The best thing you can do for both yourself and the community is to do a presentation. You will learn more about what it is you're presenting about by presenting, and then the rest of us can learn from you, and that's an awesome thing. And then all sorts of wonderful things with respect to job growth, career growth, and just your networking in the community starts to happen when you start presenting. And that's basically what happened to me. So I own my own consulting practice, Data Professionals, here in Cleveland, Ohio. I have been in IT since August of 1974. Yes, punch cards, paper tape, green bar printing, all those fun things. Done them all. I've done computer operations. I've been a developer, telecommunications, pretty much all aspects of IT is in my background. In 1992, I was on a project that introduced me to Sybase, which was called SQL Server at the time. It was 4.2. And so the company I worked for, we implemented systems using that. And then we migrated everything over to Microsoft SQL Server in 1995. I haven't looked back. I've absolutely loved working with the SQL Server engine and everything about it. So I've been doing that ever since. I was a certified IT professional, both database administrator and developer. And for a while, I was a certified trainer. Enjoyed spending time in the classroom and getting to know the people that were looking for the knowledge. Actually, Ben Miller, the guy who introduced me tonight, Ben was the person who, at the time, he worked for Microsoft, and he was kind enough to award me the MVP award back in 2007, and I've been an MVP now for 13 years. And then I was on the past board of directors for 2016 through 2018. So I was there for 3 years and worked with the team to implement a lot of changes in the organization, changes that you see today, really good things happening. So that's my background. I did start getting into PowerShell in 2008. PowerShell came out in 2006. It was 2008, the release of SQL Server in 2008 supported PowerShell for the first time, and I just fell in love with it. So let's get started. You want to capture a performance baseline. Why do you want to capture a performance baseline? Because if you don't know what your system looks like when it's running normally, then what do you look for when it's not running normally? So having that baseline tells you this is what's normal. This is what to expect. I'm going to have these spikes at this time of the day. Okay, I'd like to fix those, but I get them every day. Okay, it's not a big deal. At another point in time, I'm all of a sudden getting a similar spike, but it's not normal. Okay, let's take a look. What's going on? What is different? Without that baseline, you don't know what's going on. So we need to capture data. We want to capture data on a regular basis, but if we capture data too frequently, we're going to impact the performance of our system. You know, that's that scientific principle of anything you watch, you're technically affecting. So how often do you capture data? It depends. Most of the commercial products capture data counters every 10 to 15 seconds. I've found for the code that I'm going to share with you tonight that that about once a minute has worked well for me over time. And that's just something you're going to have to play with, that balance that comes with experience. So what counters do we work with? Well, there's all kinds of counters, and there's some that are good and some that are not so useful. There's no really right answer. So I'm going to share with you what my choices are and what are coded into the scripts that I'm going to share with you tonight. But I'm also going to show you how to choose other counters. So as we go through. First thing, the operating system counters. Now, one of the reasons I love using PowerShell is the fact that I know I am not limited to just the SQL Server counters. If I use the DMVs that were introduced to SQL Server in SQL 2005, there are performance counter DMVs there, and they're great. They give you good information, but they only give you the SQL Server counters and only for the instance of SQL Server that you're running. So now most people don't do this anymore, but you still can run multiple instances of SQL Server on the same machine. When you use the DMVs, you only get the counters for the instance that you're running them from. So in any event, PowerShell gives me access to all of the counters for both the machine and SQL Server. So let's talk about those counters. First of all, processor. We want to know how busy our processor is. So what's our percentage of processor time? If I get a processor percent time over 80%, I'm getting worried. There's something wrong, and I need to look into that. Similarly, the available megabytes of memory is important. Although best practice says only run SQL Server on a Windows server, you have other things running on that SQL Server, I'll bet you. Things like, reporting services, integration services. Those are two things that take memory that makes that memory not available to SQL Server. So I want to keep track of the available megabytes to know how much memory I have available should SQL Server need it. SQL Server wants all the memory you can get, right? Paging file percent usage tells me how much of my memory is getting swapped out to paging, right? Which is an indicator of I've got low memory. So I keep track of that just to see if that memory is being paged out, because that will cause my system to slow down significantly. The next two counters are the physical disk, average disk seconds per read, and average disk seconds per write. And these have to do with latency. And whether you're on SAN or NAS, whether you're on spinning Rust or SSD, latency is latency is latency, right? Now, if you're running on SSD, you're probably looking for something less than 5 milliseconds, where right there, the number I'm showing you is 20 milliseconds. If you're looking at latency, latency is how much time does it take for the IO subsystem to deliver the data that SQL Server is asking for, right? Or to actually write the data that SQL Server is trying to write out. And you want to keep those numbers to a minimum, so I'm capturing that information. The processor queue length counter in the system object gives you an idea on how busy your system is from a thread perspective. I had a client years ago that ran a month-end process, and they had to run it during the day, just the business requirements. They had to run it during the day. And when they ran it, it would take, 3.5 hours on a regular basis. And then when they ran it, everybody who was using the system just slowed down tremendously. And so they said, Alan, can you take a look at what's going on? Why is this run so slow, and why does it cripple us every time that it runs? So I put my counters up in place and watched the counters at month end, and the processor queue length just jumped through the roof. It was I don't know, in 10 times the average of what it normally was. It usually would bump up to 3 and 4, but it was definitely in the 40 to 50, 60 range when they ran month end. And I said, you're running a virtual machine here. They said, yeah. And I said, you've got 4 processors on that virtual machine. They said, yeah. I said, can you double that? They said, next maintenance window, yeah. I said, okay, let's do that. So they came back, and the next month end came about, and month end ran in like 45 minutes. They're like, oh my God, that's wonderful, right? It's just a matter of understanding that this processor queue length was telling me that the system was thread starved. SQL Server couldn't get enough processes running to keep up with the demand on the server at that time. So understanding what the counters mean helps you understand what to do when you see bad performance. Moving on to the SQL Server counters, the first one I'm looking at is forwarded records per second out of the access methods object. This has specifically to do with heaps. When you have a table that does not have a clustered index, and SQL Server has to rearrange data on pages because of updates, for example, what it does is it puts a forwarding pointer in the original location of the row, and that forwarding pointer points to the page where that row now exists, right? So when SQL Server says, hey, I need this data, it goes to the original page and sees this forwarding pointer, and then it has to do another read against the page where the data actually lives. When you have a high number of these, you've got some thrashing going on, and it's excess IO that's just costing you time. So you want to minimize this. How do you minimize this? Alter table rebuild is the command that now fixes that, because essentially your heap is fragmented when you see that. The next one is page splits per second. And this one is also has to do with fragmentation, but any table with a clustered index would affect this counter. Now, when SQL Server adds additional pages to the end of the table, it also calls that a page split. So take this counter with a little bit of a grain, but normally what it's doing is it's taking data from one page and moving it to another page because it physically ran out of room on that page. So you want to minimize this by defragging your indexes, essentially, is either reorging them or rebuilding the indexes, and that will help solve this problem. But keeping an eye on this counter tells you when you probably need to. The next counter under Buffer Manager, the buffer cache hit ratio, is for all intents and purposes useless, in my opinion, today. Back in the SQL 6, 6.5, SQL 7 days, this counter actually was useful. It did mean something. but with the hardware architecture that we've got today, it's almost never below 100%, right? But I keep this here because there's always some senior manager in IT that started out as a DBA and always wants to know what the buffer cache hit ratio is, right? So, you know, just as a political nod to them, I keep this counter in there. But under buffer manager, page life expectancy. The number used to be 300. It used, you know, somebody had, you know, the idea that this number should stay, which should be above 300. Really doesn't have to, but that number of 300 again is applicable to old architecture. Jonathan Cahias did a blog post years ago, and I've got a link to it in the references at the end of the deck. But he did a blog post where he explained that the data cache, the computation, if you're really interested in that, should be the data cache size in gigabytes divided by 4, multiply that by 300, and that's the number that you should generally stay above. I say generally because there are times that it's going to go to 0, and you can't control that. One of the times that it's going to go to 0 is when you run dbcc check db, because SQL Server takes all of the available memory when it runs dbcc check db. That's by design. I talked to Paul Randall himself, who wrote the code, and he said, yep, it does that. So expect that, but that's what a baseline is for. You know, when you run dbcc check db, your PLE is going to drop to 0. Okay, fine, move on. I use this counter to look for trends. What are the trends? When this drops, why does it drop? Is it because I did something as part of normal maintenance that, okay, that's the way life is? Or is it somebody in marketing ran that report that they're only supposed to run at night? Because that happens too. So that's the real reason why I use this counter. Under general statistics, processes blocked. I kind of want to know if I've got a lot of blocking. I know I'm always going to have blocking. I mean, if you just run SQL Server by itself, there's going to be blocking. But I use this as a baseline. You know, watch for changes. Under SQL statistics, batch requests per second. Throw away this greater than 1,000 is a busy system because that's garbage. I meant to pull that out of there. It's another baseline counter. Look and see what your baseline is, and when this number goes up or goes dramatically down, that's when you want to take a look. What's going on? Why are things different? I had a customer a number of years ago where if this number was in the 2,000 to 3,000 range, their system was bogging down. It was a very busy system. But I also have a friend who works for Microsoft tell me about a client of his that called him up on the phone and said, you need to get in here immediately because our batch requests per second dropped from 50,000 to 30,000. Fix it, right? So you want to keep an eye on this counter just to know what things look like normally and be available to address them when things change. The SQL compilations per second and recompilations per second, these primarily have to do when your statistics are out of date or Windows is stealing memory from SQL Server and there's not enough memory in the plan cache to keep your compiled queries in the plan cache. But principally, I've seen it as a result of statistics out of date. But when SQL Server has to spend the time to compile or recompile your code, that's just wasting cycles that could be better used on other processes. So I keep track of these for that reason. All right, how do we get this data now? So you remember I started working with PowerShell when PowerShell 1 was the thing, right? And PowerShell is built on .NET. .NET has all these wonderful objects for you. In this case, the system.diagnostics.performanceCounter object. And that object is built into .NET. You don't have to load any module, or you don't have to load any DLL or anything to get it. It's there. You define a new object, system.diagnostics.performanceCounter, assign that to a variable. That object has properties, category name. So I want processor is the performance object. I want the counter name, %processor time, and the instance name. In this case, even though I have multiple processors, I just want the overall total, right? Then I execute the next value method and get the values from that. This is, if no matter what version of PowerShell you're running, this code works. However, PowerShell 2, they said there's got to be a better way, and they invented one. It's called the getCounter object, commandlet rather. The getCounter commandlet then lets you do things like specify the computer name. Now there's a machine name property in the performance counter object, so it was replaced by this computer name parameter. You can specify a path for the counter object that you want to collect. There's a property called sample interval. Says in this case I'm saying I want 1. It's 1 second. And then max samples are, I'm saying give me 2 of these. So this is the newer way, and this is the way I generally gather performance counter data today, because this was introduced in PowerShell 2. We're up to PowerShell 7. There are things, if you were at the last meeting with Rob. Rob is one of the principal people behind the DBA Tools project, and I lost track of what I was saying there. Oh well, let's move on. So I use, oh, that's what it was. There are things that work in PowerShell 5.1 that don't work in PowerShell 7. So you're going to have to experiment with that on your own. But this works from PowerShell 2 on. To get the counter path that I referred to earlier, I can use the getCounter command and say list set and the object that I want to use. So in this case, I want to get a list set for the processor object, and it gives me this set of properties. And you notice under counter, there's kind of a collection there. Well, how do I figure out what's under there? If I take that getCounter list set on the processor object, assign that to a variable, and then look at the counter property or the counter collection within that, then it gives you a list of all of the paths that you can then use in the script that I showed you. All right, so let's go to a demo. Here we go. So again, this code works with PowerShell 1.0 and on. I'm assigning my performance counter object to my variable, assigning the category, counter name, and instance name if I don't specify the machine name or talking to the local instance, right? So I've defined it. Now I'm going to use the next value commandlet, and it comes back with 0. The reason it does that is because the percent processor time counter is an interval-based counter. So it looks at when you call it, and then the next time you call it, and that's the number it gives you. So this 1.47173 is the percent of processor time that was used between the initial call and the next call. If I run it again, my processor is pretty idle right now. It's just sitting here waiting for some work to be done. Right? So I can just keep calling that over and over again. Similarly, memory available megabytes, I'll just do all of these at once. It comes back with 1333. If I call that again, it's going to be pretty close to the same thing. It's memory is not moving around too much because, again, I'm not doing a whole lot. Again, because PowerShell 2.0 and above, I can use the get counter commandlet. I'm specifying my local server. I'm saying I want % processor time, 1 second in between collections, and bring me 2 of them. So there it did that. So the first time it ran, I was using 3.09% of processor. The next time, 0.8%. All right, so I want something more than % processor time, so I can look at the processor object, and these are the properties. I showed you that's on the slide. I essentially just did what I just did for you now and then captured that image. If I get that counter, that list set, assign it to a variable and look at the counter object, there are the paths under the processor object. Similarly, under memory, there's a lot more information available for you under the memory object. And play with these, look for things that that could be of value to you. Under the SQL Server access methods, right? Here's full scans per second. I might want to know that, right? There's all these various counters that are available to you. Similarly, under buffer manager, if I execute that, there's buffer cache hit ratio, and page reads per second, page writes per second. Here's the page life expectancy. Oh, there it is. Page life expectancy that I talked about before. So these are the things that you can do to decide what counters you want to collect for your own benefit. If I want to look at, all of the counter sets that are available for SQL Server, memory broker, clerks, buffer manager, locks, databases, database mirroring, availability replicas. There's all kinds of different counters that you can explore on your own now that you have these tools available to you. So what I did using the counters that I shared with you earlier is I built some scripts. So here I'm assigning my server name of my local server, and this is my instance name. And the counter, the performance counter's instance name for the default instance is SQL Server, right? So now I'm going to create an array here of counter paths. These are my operating system counters, and these are my SQL Server counters. And I do this way because if I'm running on an instance that's a named instance, the iname is really MSSQL $ and then the name of the instance. Like if I was running an instance called SQL 2017, my iname value would be MSSQL $ SQL 2017, and then followed by all of the rest of the path. That's why this is coded the way it is. So I'm going to define my counters. If I just highlight that variable, there's the list of counters that I'm going to collect. I'm going to use the get counter. In this case, I'm going to use that server name that I put in the variable and my counters collection. I'm going to collect at 10 seconds interval apart, but 3 times, I'm going to collect counters from this server. And then when I'm done, I'm going to pipe that counter object to the get member commandlet. To the get member commandlet, so you can see what the object looks like. get command, get help, get member are, again, the three. If you don't know anything about PowerShell, learn those three, and then you can pretty much do anything you need to. So it ran. What I got back was a performance counter sample set object that has these methods. The properties are counter samples and timestamp. Right. So what is in the timestamp variable property? There are the times. I'm in Eastern time, so U.S. Eastern time. So that's what time it is here. Those are the 3 times. If I look at the actual counter samples it collected, there they are. And you notice I've got percent processor time. I've got percent processor time here. I also have it here. And then I have it again here. Right. So it's just spilling out all 3. So I've got all those objects. Often what I'll do is I will run this command, assigning it to a variable. My sample interval will be 60. My max samples will be 1440. What does that do? That collects all of my counters once a minute for a full 24 hours. I tell the client, don't touch this, just leave it alone. And I'll run it for 24 hours. I'll then come back and use this command. Make sure I don't have one there. Yeah, it doesn't look like I do. Nope, counter. Nope, I don't. Okay. So I'm going to run this command. This exports the object inside my, from within my PowerShell session into this file. I can then copy that file to my own system, bring that into my own system, import that from that file. Now that's in new counter. And you notice in new counter, now I have the same data I originally had. So it didn't change the data at all. It brought it back to me. And so what I'll do is I'll take that 24 hours of counters, bring it back to my system, use my script and load it into my SQL Server database and look at the data. If I am running on the server where I'm capturing the data, here's the full script. And I've provided these scripts to Ben, but here's the part that I've already walked through of defining the counters. Here's the get counter command. The rest of the code is just parsing out the individual counters, getting the cooked value for each of those counters, putting those in variables, then sending those variables as parameters to stored procedures that load it into the database. Okay, so I'll let you, and then what this script does is it goes to sleep for whatever interval I've specified in the parameters and just keeps on doing that. That puts that data into my server analysis database, specifically into server stats and instance stats tables. And from those tables, I then have produced these reports. I've provided you with the DDL for the database. I've provided you the RDL for these reports, as well as the scripts that I'm showing you, okay? So when I say get a baseline, you notice there's a pattern here through the day. These are subsequent days of activity. So I generally, by the way, the current one is only a partial day. The way I'm using sparkline graphs here in these reports. And a sparkline graph, whatever data you give it, it spans the width of that graph. So most of these are 24 hours of data. The first one is from midnight to whatever time I ran the report. Right. So, but other than that first line, it's essentially 24 hours of time. The other thing that's interesting is like weekends. There's not a lot that goes on the weekend. Look at how that grows. And then we've got this massive drop off, and these lines are significantly smaller than these. Well, in reality, they're not. It's just that my page life expectancy grew so high over the weekend that it needed space to show all of that, right? If I click on the date, the 19th, I'll go to a second report that's just the performance analysis report. And you can see my page life expectancy grew to 80,000. We ran DBCC check DB, and that dropped it right back down. And here's the rest of the activity for the course of the day. But I have the actual numbers here. Here's my percent processor percentage during the day, how busy the system is. My buffer cache hit ratio is in yellow up there. My batch requests per second. You can see where the bulk of activity happens in the day for this particular system. Blocked processes and processor queue length. So you can see I'm jumping up at a number of times, but generally during the business day, I'm staying down below 5, and that's a reasonable number. Okay. So if we go back to our slides, the other thing you want to do is you want to track your disk and database history. You want to know if your disk drives are going to fill up, because if they fill up, that's bad. Things stop happening. You know, your databases just come to a screeching halt when they run out of disk. By tracking that disk space usage, you can kind of project when you're going to run out, and you can go to the boss and say, hey, boss, in about 6 months, we're going to run out of disk space. Can we get some more? And generally they can deal with that because that gives them time to go through the budget approval and all that kind of thing. But if you go to the boss and say, hey, boss, we just ran out of disk space. I need some more. We need to buy some now. It doesn't make you look very good. And so I generally try to keep track of how much space is being used over time so that I can anticipate when I'm going to run out. Same thing with the database space. Whether, you know, I don't know if you know this, but auto grow is both a blessing and a curse. It's a blessing because you don't need to manually set it. Back in the SQL Server 6.0 and 6.5 days, and even before that, of course, you had to define in advance the amount of space that your databases were going to use. They didn't auto grow. If people started putting more data in there than there was room for, things just stopped, and that was bad, right? So auto grow helps you solve that problem as long as you've got disk space for it. The downside of auto grow though is when you use auto grow and SQL Server says, hey, I'm running out of disk space, I need to grow, all of the activity in that database stops while SQL Server grows that space. That may not take long if you're on SSD. It may take some time depending on how much you need, right? You're letting that database manage you, and that's not a good thing. So if you keep track of the amount of space that a database is taking, you can manually grow those databases on the weekends when you're not going to affect anything, right? So you're really doing a better job of managing your systems by keeping track of the amount of space you're using, and then acting in time to prevent any problems. So again, I've provided scripts in the download. There's a script here, and essentially I'm using Windows Management Instrumentation, or WMI, to get the information about the disk. So Win32 logical disk is the WMI object that tells you, that Windows will tell you how much disk space you have. Its drive type equals 3. And then I select out the name of the volume. Device ID and volume name are usually pretty much the same thing. Size and free space come to you in bytes, right? So I use one of those wonderful features of PowerShell where I divide those values by 1 gigabyte, and it gives me the size and free space in gigabytes. And then I store that data in my database using this stored procedure. Similarly, get database usage. I'm using, in this case, I'm using SMO. So I'm going to connect using SMO to that instance. And then for each database in my databases collection, first I'm going to check to see if it's accessible. So if I'm in well, I used to regularly say database mirroring. The mirror side is never accessible. In the case of availability groups, you may or may not have the database accessible, right? But if the database is accessible, then get the current date and time. And then I'm going to execute this stored procedure. I'm going to give it the instance name, the date and time, the database name, the collation, compatibility level, whether or not auto shrink is turned on, because I want to check that regularly. You know, there's always somebody that's going to turn that on because they think they're saving space, and it's essentially that should be called auto fragment. What recovery model am I on for this database? The size is reported in a database in megabytes, but the space available is reported in kilobytes. So I divide that by 1024 so that I have size and space available, both reporting in megabytes in my database. And I execute that stored procedure, putting the information in there. And yes, I have reports. So if we go back to disk usage analysis for my CleSQL 01 server, the C drive is pretty static, but my backup drive, it's 350 gig, and you see the actual free space floating around during the course of the last few weeks. So, but it's not going down tremendously. It's starting to kind of trend down, but not enough to be worrisome at this point in time. So, and similarly, database space analysis, my Cleveland server, and I'm going to move forward to this particular database. You see, I'm pretty much fixed at almost 1.4 gigabytes. But you notice I start off with 86 meg available, and by the time I get down to the bottom, I've only got 18 meg available. This is a database I need to pay attention to. I need to go and figure out why is it not auto growing, and what do I need to do to make sure it doesn't run out of space? And I need to do that pretty quickly. How do I know that? I see that in the chart. Okay. References. This is the article that John Cahias wrote, where he explains about the the number you should expect in page life expectancy. As far as getting the performance counters, getting those list objects, Bo Prox's blog post from February of 2018 does a really good job of walking you through that. Greg Larson did an article, what are the top 10 SQL Server counters for monitoring performance? Greg wrote a great article here. I wrote an article when I was working for SentryOne at the time, and I essentially covered the counters that I covered in tonight's presentation. I also wrote a whole series of articles for what was SQL Mag at the time. These are now available on the IT Pro Today website, that are all focused on using PowerShell to manage SQL Server, various aspects of using PowerShell to manage SQL Server. So those are available for you. Ben, I apologize. I meant to ask for questions after the first demo. Any questions?
No, you're good. The questions have been coming in, but I've been able to answer the ones that, things where to get the scripts and stuff like that. So
Okay.
no other questions so far.
Well, and you guys all know that Ben is pretty much a genius when it comes to this PowerShell and SQL Server stuff. So
You're too kind.
well, so that covers everything. I'll leave these up there for a little bit of time. But these slides are all in the download with all the links, so you can go directly to those. You can also reach me. I'm a SQL RUNR, SQL Runner on Twitter, or you can reach me at my email address. It's awhite@dataperfpro.com.
Cool. Thank you, Alan. That was great. It was. It's good to see it in action, and I like to see the PowerShell working, and the reports were awesome. So thank you very much for putting that together. I think it'll be a good addition. And again, one of the big benefits of having a pro teach you things on the screen is that most often the pro is going to give you something that you can reuse. The reports you can adapt, you can add more counters, you can do lots of things and put them in tables. So it isn't just, take this and run, which you can do, but the benefit is that you can take and adapt to what you do, or maybe your environment's a little different, or maybe you want one more counter, one of your favorite ones, and you can just add that to the list and add a column in the table and let it rip. So it's really kind of nice to get some of this stuff where you can take it with you and enjoy the rest of the presentation on your own. So the only other announcement we have, there's no more questions, so thank you, Alan. There will be a presentation on Thursday. Check out the PowerShell.pass.org, and there will be a presentation. I'm going to be gathering trending data, so kind of like what Alan's doing. He's doing perf counters and baselining. I'm going to do the same thing with the principle of taking what I'm going to show you, and you can adapt it to whatever you want. I'm going to show you some of my favorite things to gather for trending and show you how I use them. I gather database space and stuff like that, but there's other things that I gather that it is a little bit maybe not thought of, but I find it fascinating to do a baseline on indexes and things like that. So we're going to show you some of that in the next presentation on Thursday. So please join us. The registration's on the PowerShell.pass.org site already, so feel free to plug that in. We're just doing a quick end of June kind of thing to finish out Pass's fiscal year, and we're just kind of doing our own little marathon in the end of June. So thank you, Alan, for your time, and we'll catch you out on the interwebs.
All right.
Thanks, everybody.